So I'm going to go down, again, a list of questions in thematic order with some of the things that struck me from the conference. So does physics need to know what an observer really is? I think probably the whole conference was predicated on the answer that it was yes, but it certainly is a more nuanced question than that. So even the Copenhagen interpretation we learned from that doesn't involve collapse, as the textbooks seem to say. So probably we don't need an observer, or doesn't have any kind of role in our fundamental theories, in quantum foundations at least. But in cosmology, we do seem to need some kind of notion of observer to understand selection bias and handle these Boltzmann brains and so forth. But then at perhaps even a more basic level, how the heck do we connect the ethereal world presented to us from fundamental theory to what we actually see? Physics being an empirical science, after all, we do need to make that connection. And of course, the great tragedy of the progress of physics is that the more we seek to explain our experiences and collate them into a comprehensive view, the further we go from those experiences. So somehow we need to go through the stepping stones and get back to what we directly see. Now, this question of operational reasoning, I think Carlo brought it up at one point, but it's come up implicitly in a lot of the talks. In theory building, of course, we do invoke the observer. What is it possible in principle, at least, to observe? And if it's not possible, at least in principle, to observe that thing, we doubt the existence of that thing. So we do bring up the observer in a lot of contexts other than the standard ones like Copenhagen. This came up actually quite nicely in debates we just had, the first versus third person view of what physics should be telling us. Maybe calling it reality is a little highfalutin, but certainly are our theories observer dependent, or do they need to be observer dependent? And we heard differing views on that, both from cosmology and in the foundations of quantum mechanics. And then a question that I'll just pose: suppose we do decide that our current theories have this unavoidable observer dependence in them, be it the causal patch or the relational quantum mechanics or what have you. Is that something we should settle for? Or does that just push us to a more complete picture? Is there such a complete picture impossible? And if it is that sort of an end of science argument? Are we back to leaving some kind of part of reality beyond our capacity to capture? This also came up in the debates, and perhaps some clarity was brought to it, or at least some useful lack of clarity was imposed upon it. Does physics really need to know what consciousness is? Does it need an IIT-like theory? Apart from our general interest in what that consciousness is as human beings, as physicists, do we need to know what consciousness really is? And we saw different points of view on that. Janan really argued that it's really the functional aspects of consciousness, the outward, what we see from the outside, that matter, and that you can think what you like or be a zombie inside your head. It kind of doesn't matter for understanding the physical world. Carlo said something similar, but it was almost a more, if I understood Carlo, more kind of epistemic question for you, that if we really need to wait on the neuroscientists, then we're going to be waiting a long time for that kind of thing. But then we heard alternative views from some of the IIT folks, for instance. I think, was it Giulio or Musser who brought this up quite quickly? There was that evolutionary model showing that under a resource constraint, a being with some kind of internal feedback loop, and hence by that model, phenomenal consciousness, is actually more efficient than a zombie. The zombie requires a larger feed-forward network only. And then David, of course, argues, and has argued eloquently for decades, the hard problem that our current scientific framework just seems plain inadequate, and therefore we need perhaps to put consciousness in our fundamental ontology, and to the extent that physics aspires to universality and universal explanation, if physics is to include consciousness within that universal explanation, it too needs to think about what it means. So, my first audience poll, actually, I think A, B, C, D, which do you prefer? Disjoint, that physics and consciousness are disjoint, that there's some overlap, that physics subsumes consciousness, or the other way around. So who thinks A? 1A, 2 A's. B. That's looking good. C. Wow, almost tied. And D. So I think it's a tie between B and C. So Carlo, in the first or second talk of the conference, told us that all the things we thought existed, at least kind conventionally don't seem to in a quantum theory of gravity. We had an interesting debate, or not really a debate, but an interesting discussion throughout the conference on whether the multiverse is predicted by our theories or perhaps even exists, whether consciousness exists, whether you can bootstrap the whole thing from some very minimalist structure in quantum theory. And then, of course, maybe that concept of existence doesn't seem to exist. We debate over whether that's a meaningful thing to ask. And I have to say, just coming to this really as a layperson, or putting my layperson hat on, to be told by scientists that they don't care what exists is a little bit of a, I can understand the point, the humility that we need to bring to our subject, that we need to start with what we know or think we know, observations, and try to explain that and avoid endless debates over what's really out there that may be inaccessible to us. Nonetheless, if you ask a member of the public, what does physical science do? Pure physical science do? They'll say, it tells us what exists and what happens to what exists. Boltzmann Brains, I think, have come up at every single FQXi meeting, and we still don't have a resolution to it yet. Sean tells us we kind of don't need to worry about it. Well, we do need to worry about it, but it's pushing us in a certain theoretical direction, and we got that from some other people too. And maybe it pushes us to a certain measure, such as the causal patch measure. And then there's the possibility from yesterday that actually the brains aren't even conscious to begin with. We don't have to worry about being one. This was quite an interesting debate, and it came up in literally the debates we just had. Are events fundamental? And actually, an interesting observation about the two subject matters of the conference. Event is almost over-defined in our physical theory. I mean, in relativity, it's a point in the continuum, and observers are under-defined in our theory. And we need to perhaps loosen our definition of event or clarify it, because a single point may not even exist in a sense. And then we need to be more specific about what observers are. So we're kind of going in two different directions on our definitions of these things. So I'm somewhat sympathetic to Emily's point of view on this, because I just wrote an article, magazine article on GRW and CSL and the flash ontology. But then again, it's conventionally we think that there's a deeper level out of which the events might come, and that, as Matt and Ken and I think others have pointed out, this ties into the general debate over the interpretation of quantum mechanics. Bill is here. He had that interesting clock, trying to figure out how to even know or position things in time or space. That little clock model. So this is something, I guess the FQXi meeting was all about information, and yet we have unfinished business from that meeting as well. What is information about? We use that word a lot, and with the clarity on it remains questionable. So again, the idea that information is really just locating us in a vast ensemble came up actually in the very first talk of the meeting. Sean would, I'm sure, and Steve as well, object to my second question here, so I'll just leave it as a question from me. If it's Hilbert space and it's a state of space, a space of states of blank, I don't know what, maybe nothing, but one does want it to be states of something, at least that's my intuition. And then questions of meaning. This actually I don't think came up so much in FQXi, but the semantics of our information are important, and a number of people brought that up, at least as why do we observe? Why do we gather information out the world? To survive or to achieve some other goals that biological systems have. So we give meaning to that information. And we heard that also in the context of IIT, that there's this external or extrinsic and intrinsic view of information. This wasn't an explicit theme of the conference, but did come up in a lot of talks, so I wanted to point it out, that we conventionally just equate observer with human. So whenever that comes up in a theory, we imagine our performing an observation and try to formalize that in some way, but there was some effort here to try to generalize beyond the human to some kind of thermodynamic system or pattern, perhaps even things we don't regard as discrete entities. So an entire species of organisms over evolutionary time might be thought of as observing its environment, and I thought that was pretty cool. And then actually this really struck me from Bart's talk about the Erdos discrepancy, maybe the third or fourth talk we had, that the computer understands the proof. It didn't just brute force it out. It actually has an internal reasoning model that we humans haven't been able to replicate. At least no one person can really grasp this, and it's extremely subtle mathematically. So it reminds me of, I guess, Kasparov when he played Deep Blue. Was that right? He remarked that the machine seemed to have a consciousness to it. It seemed to have some kind of deep understanding of the game. It wasn't just brute forcing it out, and that seems to be the case in math as well. This is my term for what Jim mentioned in I think, a remark. Comparative observerology. I think maybe this will become a field in the next coming years as we build observers and computers reach human level that will actually have other observers to compare. Now, my background is actually in planetary science, so I'm quite sympathetic to a comparative program, because how do we understand the Earth? We understand it by comparing it to other planets, and climate change actually being an example partly of that, comparing ourselves to Venus and to Mars. So will we ever understand ourselves until we have other human-like or human-level consciousness to compare ourselves to? And I'm told that even my computer operating system has a degree of at least effective free will. It depends how you define free will, but it can't predict its own outcome because of its internal loops. And the next two slides are a little bit of a cheat because I didn't know how to pull it together into a theme, but I wanted to remark on something that actually didn't come out in the reverse debates, and that was we heard about a lot of awesome experiments. And I couldn't plot a theme of those experiments, but man, there were some great ones. Paul, in his opening remarks, his opening talk, described a number of them, but one that's always struck me is that there may be other forms of life on our planet that we have yet to find. How would they might use different biochemistry or stem from a separate second genesis. We heard about different quantum mechanical experiments, including ones of astronomical scale, ones that are quite tiny but almost at our human scale, some of these micromechanical systems, for example. And then we got into some pretty great stuff. Max, you mentioned this during, I think, a comment that maybe some of these systems are so sensitive they could pick up dark matter. And then the idea that there could be some modification to quantum mechanics that leads to higher order interference terms, looking for that. And again, simple experiment that can be done, or fairly simple experiment that can be done. And Bill just almost offhandedly pointed out that the LIGO mirrors, I guess they're probably the largest systems we now have that exhibit quantum behavior. Is that what you were claiming, Bill? The quartz mirrors. And finally, the Foundational Questions Institute itself, a big experiment started 10 years ago, and thanks to all the funders that we heard from during the Science and Society session. So I have instead of my final words, I wanted to leave the final words with people more eloquent than me, and I chose some of my favorite quotes from the meeting. Okay, I'll read them out. I can calculate the motion of heavenly bodies, but not the madness of men. Matthew Fisher was quoting Isaac Newton. Life is pretty much overrated. I think this was in response to something about consciousness being overrated. Life is pretty much overrated. Most people are dead most of the time. And Suzanne captured certainly a view that a lot of us have expressed, that to observe is to become confused by. Observers are beings who think they're me. And again, 15 years ago, we had a cover of Scientific American that I think it was called Is Space Finite? It was about non-trivial topologies in cosmology. And Andy Rooney had it on his segment on 60 Minutes saying, we look to science for answers, and here we just get more questions. So you tell us whether space is finite. So he was making fun of us on that. So we outside physics turn to physics for answers, and to be told from Laura, I don't know the answer, I'm just a physicist, is a little disconcerting. Anyway, thanks to you all for listening.